Hey guys, we learned about the mole in this last video, but today we want to take the mole a step further because we said we have to count things by mass because we can't count things by atom because they're too small, and that's why we have what?
We call it molar mass.
The molar mass, so the mass of 1 mole. So what is the definition of a molar mass?
So literally it is, we take a mole of anything,
Yeah.
and we put it on a scale, and however many grams that is, that's the molar mass.
So I have the element gold right here. You know, from our cool yellow periodic table, there's some numbers on there. Can I figure out the molar mass from this yellow table?
This is the beauty of this table. We had some very smart people a long time ago. What they did is they measured the average molar mass of all the particles on the periodic table.
So we know that gold has a molar mass of, as you can see on the board, 197.0. So how would you write that as like a conversion factor?
Well, anytime we have two things that are equivalent to each other, we could say this: 197.0 is equal, this is grams, is equal to 1 mole of gold.
So the atomic mass on the periodic table is the
Molar mass.
mass. Now, could you write that like a fraction since they're like
And
equal?
we often do this to make it a little easier. So for ourselves, we say 197.0 grams per mole.
In
And we
fact,
consider
one
this
thing
to be
I would
moles.
encourage you guys is not to write the slashes. You can there, but when we start writing them, when you do problems, you write it over 1 mole, right? So that's important to know. So that's just pure elemental gold. What about if we have a compound like FeCl3? So now we have a compound. Remember we learned about compounds in our last unit. So what if we have FeCl3?
Well, here's the thing. If we are different masses, would you agree? Like
Yeah.
you couldn't take your mass and go, oh yeah, there's 2 of them, so multiply your mass by 2 to get our combined masses.
Iron weighs different than chlorine, and we know there's 3 chlorines.
Right. So just like we would, if we wanted to measure our mass, wouldn't I step on a scale, you step on a scale, and when we add it together,
yeah.
we do the exact same thing with atoms.
So I'm looking at our cool yellow periodic table here, and it says it's 55 point.
This is what happens when you get old, right?
Hold that thought. Mr. Bergmann needs his periodic table. I think it's 0.85. 55.85. So that's the weight of Fe.
Okay.
But we have chlorine. I'll tell you what chlorine's mass is. It's 35.453.
Now, watch. Since we have 3 of these, what we could do is we could say 35.453, 35.453, and 35.453. Or can we just say that we're going to multiply it by 3?
Yeah, so I'm just typing in my calculator. In fact, why don't you write this down? This is how I'm going to actually type in my calculator. 55.85 plus, and I say 3 times 35.453. And I get 162.209. 162.209. And that's going to be units of grams per mole. Got it? So it's really simple. You add them up. All right, let's do one that's a little trickier. I'll just shut up, let you erase, and I'll cut that out. How about we do MgOH2?
What you've done is you've introduced the parentheses.
Yeah, remember the parentheses means there's, how many O's and how many H's are in MgOH2?
Well, it's kind of like in multiplication whenever in math. When
Yeah.
if you have something on the outside of a parenthesis, you multiply. So it'd have 2 O's and 2 H's. So it may be helpful at the beginning just to keep a track of the things you have.
Yeah.
We have 1 Mg.
Mg weighs, all right, Mr. Bergman's getting his little glasses, 24.305.
24.305.
And then O weighs 15.999. And then little hydrogen, 1.0079. So we just need to add those bad boys up. But we have a little trick here, is that there's 2 O's and 2 H's. So on my calculator, I'm just going to add those numbers. Watch how I do this. I'm going to say 24.305 plus 2 times 15.999 plus 2 times 1.0079. I'm not putting any parentheses, by the way. The calculator kind of understands order of operations, and I get 58.3188.
And again, that elusive unit is grams
Per mole. Now the next one in your notes sheet here is ammonium sulfate.
Ammonium sulfate. I vaguely remember this from our last level, correct?
Yeah. So now we've got a compound, and we have to actually figure out the formula. So you have to look on the trusty dusty sheet. What is ammonium? That's NH4 positive 1. And sulfate is polyion, they're both polyions, SO4 2 negative. Now we have to add the charges up. Do they add up to 0? You guys remember this game? Mr. Dmitrowicz? Yeah, so we need 2 ammoniums and 1 sulfate. So what's the formula of ammonium sulfate?
And remember, we have to put parentheses around this because it's a polyatomic ion that we have more of them of. And this is, by the way, a level of ugliness, is it not?
Yes. Now, on this one, let me show you a thought I had on how this also might work. So for nitrogen, it's 14.007. So sometimes I'll just do this. I'm going to shorten it up. And then for hydrogen, so you want to write this number down,
Sure.
Mr. Dmitrowicz, this is 1.0079.
Okay.
And then for sulfur, just kind of do a little liney there, yeah. Sulfur is 32.066. And then oxygen is 15.999. Now, what I would recommend, this is the shortcut if you're ready for the advanced version, is I need to identify how many ins are there here.
There's 2.
So, yeah, so put a 2 here. How many H's are there? Now this is a trickier one.
Remember, anything on the outside multiplies what's on the inside. So it would be 2 times N, and it'd be 2 times
H, which is 4, which
4.
is 8. So they put an 8
I'll use
under
the
there.
black just to keep it, I want to put the black
Yeah.
mark in there just so we keep it.
So that's an 8. And then for the S, he's by himself, there's 1. And then the O, there's like no multiplier here, this is 4.
Well, hold on a second. Why didn't we multiply this 4 by the S as well?
Because there's no parentheses around SO4.
So you only apply, like in this case, we applied to both these things because there's a parenthesis around.
So what I'm going to type into my calculator is 2 times 14.007 plus 8 times 1.0079 plus 32.066 plus 4 times 15.999. And I get a grand total of 132.1392.
Now, we can talk about significant figures here if we want to,
Yeah.
but
Honestly, one thing I would recommend, guys, is that at some level, it's not going to be a big deal. Is if you probably, when you're done, rounding it to the hundredths place is probably a good place to, generally speaking. So I think we could probably safe to say when we get these big long ones with 4 significant or 4 places after the decimal, let's just round to the hundredths place.
I'm still using the slanty here, but if it'll help you to remember, let's remember this is grams per mole. And by the way, when we have this, we now know that 1 mole of this ugliness, if we scooped it up and put it onto a scale, it would weigh 132.14 grams.
Mm-hmm. And one thing I also, Mr. Dmitrowicz, I might change this a little bit. I might just say per 1 mole, so that
Sure.
when they do the math, because this is going to become, if you will, a conversion factor that you're going to understand in a subsequent video. All right? So guys, that's how we do molar mass. You just add from the periodic table, add them up, and then review when you're done, like we did here, round to the hundredths place, probably a good place to go once you've added them all up. And yeah, molar mass, simple idea.
See you next time.